One of the most exciting things to me lately is looking at the trend of model autonomy. Now, what inspired this video is I saw a news clipping that showed that Replit, which is an agentic coding company, is now valued at about $3 billion. So let's talk about where agentic autonomy is going and what it means. So real quick overview, Replit hits $3 billion valuation at $150 million annualized revenue. One of the things I want to point out is that a lot of people kind of make fun of these companies because they're basically LLM wrappers. However, these companies are adding more to the stack rather than just being a wrapper for the LLM. Because one, many of these companies are LLM agnostic, meaning they can pick whatever model you want at the customer end. But then also they're adding more value to the stack, namely the agentic framework, which that's the real moat. So one of the jokes has been over the last couple of years, every AI startup is basically just a wrapper and has no moat. But this is no longer the case because these agentic frameworks on top of it are increasingly sophisticated. So this tweet is really kind of what set it off. So Amjad is the founder of Replit, and he's in the news quite a bit. And one of the things that they said is that for Agent V1, it was able to do 2-minute tasks, Agent V2, 20-minute tasks, and Agent V3, it was able to do 200-minute tasks. So that's going up 10x. Now, obviously, there's no, there's not really an x-axis here. It's just over time. So this is more of a marketing graphic than real data. But one of the things that I'm hearing from a lot of people is that the METR paper, so that's METR, which I'll talk about in just a second, actually dramatically undersells what these tools can do. Yeah, there are some news from private news from industry that really knocks your socks off just what Claude can do on its own without these agentic frameworks on top of them. So you have this two-way interaction between the model itself, which is getting better and better, but then the agentic frameworks that are built on top of it that are also getting better at the same time. So that leads to data like this. So this is the famous METR graph that shows that over time, you can see a very clear exponential curve as the baseline models become more autonomous and they're able to do longer and longer tasks. Fortunately, METR releases that data, which I take that data every time that it's updated and give it to like ChatGPT Pro or Gemini and ask it to do some regressions on that data. So here is the latest result of doing those regressions. Now, I learned from all the modeling and forecasting work that I've done with the help of GPT-5 Pro and deep research and all those other tools that when you're trying to understand data, one of the best things to do is test different models on it. And when I say model, I mean mathematical models, not AI models, although trying different AI models is important as well. So I handed the raw data to it and I said, figure out which model best fits this data. Is it an exponential? Is it a super exponential? Is it logarithmic? What is the best data? And as it turns out, the steepest curve is the best fit of the data. So answer in one sentence. On the raw METR data set, 28 points, the best fitting trend for model autonomy is a super exponential, specifically a stretched exponential of the form y to the t equals a exponent bt to the c. And where t is years since 2019, February 14th, when the data started. So effectively, we're on the steepest slope. So this is not just an exponential. It's not even just a quadratic exponential. It is a stretched exponential. I'm not strong enough in math to really understand the ramifications of this. I'm relying on the AI here, but curve gets steep. That's kind of the takeaway here. So once we derived this formula, I said, okay, forecast this out to 2030 and tell me what we see. And so we see here where right now we're in the 10 to the second, so that's 100 minutes, give or take. But then it's stretching up very quickly, and we see that by 2028 we're looking at 10 to the 6th, and then by 2030 we're looking at 10 to the 10th autonomy. So okay, that's what it looks like on a graph, and this is you can see the fit is pretty close. That's a very good fit. Now, one thing I will say is one flaw with my methodology that people pointed out on Twitter is there's different things you can do where you can drop some of the samples, so you can hold out a third of the samples or a quarter of the samples and then test accuracy. I did not do that, so your mileage may vary, but also this is just done, back of the napkin math with the help of AI. But with that being said, the curve that we derived shows these thresholds. So by July 1st of 2026, we should expect to see about 1,547 minutes or 25 hours of autonomy. The following year, July 1st on 2027, 857 hours, which for context, that's about a tenth of a year right there. So that's over a month of autonomy by 2027. By the middle of 2028, we're looking at 59,000 hours of autonomy on this curve. 2029, 8,600,000 hours of autonomy. And then finally, by 2030, we're looking at 171 billion minutes, which is 2 billion hours or 323,000 years. Those are big numbers. Big numbers get bigger. Now, what I want to point out is these numbers are functionally meaningless because essentially this means that, these agentic models, these agentic coding platforms will be able to succeed, at a 50% accuracy at tasks that take longer than humanity has existed before too long. And that is not the time step that reality works at, because, is it going to sit there and code something for 323,000 years? No, it's gonna run into resource limitations before that. It's going to run into permissions issues before that. It's going to need feedback before that. So essentially what this means, though, is that model autonomy is going to be, for all intents and purposes, functionally solved in the next few years, meaning that the level of success for a model working on those longer time horizons is not going to be a bottleneck. So that begs the question, what will be the bottlenecks? But first, I had this funny question. I said, can you calculate when would this model predict that AI autonomy exceeds the heat death of the universe to show how ridiculous the curve is? Give me the exact date. So it used our winning formula and figured out that model autonomy would exceed the heat death of the universe, which is 10 to the 100 years. And it predicted that it will hit that in 26.6 years, or October 22nd, 2045, which is right in time for the singularity. So basically, model autonomy will exceed, at this current rate, which of course there's reasons that it's not going to get there, but at the current rate, if it continues, it would exceed the heat death of the universe in terms of how long it could function autonomously, right in time for the singularity. So that's how ridiculous this data is. But that's also why I say it's functionally meaningless. But what it does mean in practical terms is that the bottleneck is going to move. So before we get into the bottlenecks, I wanted to share this paper that popped up. It's a preprint, so take it with a grain of salt. But the central idea for this paper is the illusion of diminishing returns measuring long horizon execution for LLMs. One of the core insights, and this is something that I independently came to, which is one of the reasons that I latched onto this paper and said this is worth sharing, is because when you go from 90% success rate on one-shotting tasks to a 95% success rate in one-shotting tasks, you might say that's only a 5% increase in success rate. No, you're doubling the success rate because you're cutting the failure rate in half. Instead of failing on 10%, you're only failing on 5%. And that is the mathematical intuition that many people don't have if you just look at 90 to 95%. And so what they find is that when you get those last few percentage points, going from 90% success rate to 95% success rate, the long horizon execution goes up very, very quickly. And so then I was very skeptical about this kind of reasoning in the past. You might remember, for people that have been with my channel for a long time, that I've been talking about sigmoid curves. Guys, watch out for the sigmoid curves. We're going to hit diminishing returns. But in the last year or two since I started saying that has not proven true. And one thing that people said is, yeah, there's going to be another sigmoid curve. So you have one sigmoid curve after another, like a stepping stone. And that is exactly what we have seen. So in this case, the first sigmoid curve was just model scaling, more parameters, more data. The second sigmoid curve that we found was test time compute. The third sigmoid curve we'd have is long execution, or long horizon execution. And then the fourth sigmoid will probably be something else. Maybe more supervision or synthetic data or whatever else. So every time we feel like we're hitting a wall, we're not. We come up with another opportunity because the mathematical search space about how do we use these AIs more is functionally inexhaustible. And when you look at the amount of data that human brains require and the amount of energy that human brains require, That is, for all intents and purposes, our current floor. We know that the human brain can generalize with a lot less data and a lot less energy than our AIs are doing. So if our brains can do it, and our brains are not magic, I mean, they're magic insofar as we don't know how they work yet, but they clearly do work. Therefore, we're still many orders of magnitude above the efficiency, both in data and energy, of the human brain. So there's going to be probably, 8, 10, 20, 50, maybe 100 more sigmoid curves of efficiency gains and intelligence gains over the next decade or two. So then that leads to, okay, if agentic autonomous coding is not going to be the bottleneck, what is going to be the bottleneck? So model autonomy will quickly outstrip other bottlenecks, namely humans. We're going to be the bottleneck soon, and in many cases we already are. So first is task specification. We'll need AIs to take over task definitions, which means, rather than humans writing user stories and cases and all those kinds of things, just have the AI do it. So that's something that they're already pretty good at anyways. You just need the right inputs. Next is access and permission. So that's, do they have the right resources, role-based access control? Do they have enough data? Those kinds of things. Keeping them in sandboxes will actually hamstring them. And what I mean by that is if you keep it in its own little coding environment and you don't give an agent the ability to request access to resources and have another agent grant those resources or deny them according to what they need, then, it'll just get to a point and it's like, sorry, I can't help. I'm waiting on other resources, or I'm waiting on a human to approve it. And that goes to verification. Who's going to validate and integrate the output? So we need validation agents. We need agents that do unit tests, that do integration tests, and those kinds of things. Because without that, you're going to be waiting on humans to manually integrate things. And of course, manual integration hasn't necessarily been a thing for a while, particularly in big shops, because you have fully automated DevOps pipelines, which then allows you to automatically test and deploy and stage everything, yada, yada, yada. But anyways, not every shop does that. So there's a lot of alpha in building agents that can do verification and DevOps agents. Next is remediation. If something goes sideways, then you need to have a backout strategy. You can have SRE agents, which is site reliability engineer agents, and those kinds of things. Compliance, legal and regulatory frictions. Also change management, making sure that the changes are properly documented and that kind of thing. Again, perfect for agents to do because everything is going to be API driven. Safety, which includes cybersecurity and even X-risk agents. You can build agents that say, hey, if we deploy this, is it going to threaten humanity, or is it going to, present cybersecurity vulnerabilities or that kind of thing? And then finally, coordination. Agents that are just little pigeons to carry messages from one silo to another. Those are all going to be bottlenecks by 2027 when agent autonomy is the biggest thing. So if, as a business, if you want to get ahead of the curve, start thinking in these directions and figure out how can we alleviate those bottlenecks, because you're going to be writing literally billions of lines of code per day for pennies on the dollar within just a few years. So if you have a hyperabundance of code, how do you test that code? How do you integrate that code? And this is kind of the primary thing is we're coding up the matrix. Unlimited software is coming soon. Businesses should start preparing for this future now. The bottleneck will shift from writing code to coordinating work, managing risk, and coupling software to the messy outside world. The right CEO plan is to build an autonomy-ready operating system for the company, a platform, process, and governance stack that can absorb near-instant code and turn it into safe, observable, and reversible change in production. So number one, throughput. Treat code generation as abundant and plan for orchestration to be scarce. That's going to be the new scarce bottleneck, is how do you organize all of that? Next is enablement. Move to software-defined everything so that agents can actuate change through APIs and policy, not tickets and meetings. Have the agents meet on their own. You don't need humans in the loop. And but then what you do need is you need a dashboard so that humans can watch all the agents, because you're going to have literally tens of thousands of agents doing stuff. So you're going to be watching them like message queues. In fact, putting them on AMQP would probably be the best way. So AMQP is Automated Message Queue Protocol, which is a way that applications can talk to each other. In fact, that's one of the first things that I tried to do with cognitive architectures. I said agents should use AMQP because it's routable messages. And what are these? They're talking with messages. Anyways, sorry, getting into the weeds. Checkpoints make governance executable. Policies, approvals, risk limits, and audits must run as code inside the delivery machinery, not as out-of-band committees. That is going to be one of the biggest things. Okay, so Thanks for watching to the end. If you want more like this, I have my courses going up over on First Movers, plus a whole bunch of other courses. It's not just me. So go to firstmovers.ai/David-Shapiro and or use the sign-up code Dave Shapiro to get a discount. And thanks for watching to the end. I will check you all later. Have a good one.